Alright, this video is going to be about 1.9 through 1.10. Last video we talked about horizontal asymptotes, slant asymptotes, and the different types of rational functions. In this video we're going to be talking about holes and vertical asymptotes. We're also going to be talking about how the functions actually work. How can we take a graph and turn it into a function, and how can we take a function and turn it into a graph. Right? So first thing we're going to start out with is holes and vertical asymptotes. So if we look at this equation, and it's asking us, give us the vertical asymptote and the holes, if there are any, right? So obviously our first objective here is to factor. So if we take this bottom one, immediately it can be x, let me put this a little higher, x times x squared minus 4. And then from there we can factor x squared minus 4. Difference of squares, x plus 2, x minus 2, x. So that's our denominator factored. Now let's bring this one around. X squared plus x minus 6. Alright. So immediately we know that we have to subtract by less than how we add, because it has to end being positive. So that means the number that is subtracted has to be less than the one that's added, and it has to be within 1 away from each other. So that means it's negative 2 and 3. X. And then you cross over, you go x plus 3, x minus 2. Boom. So let's move these where they're supposed to be. This is the numerator because we took it from the top. And this is the denominator because we took it from the bottom. Perfect. Okay. Now, how do we find hole? How do we find vertical asymptote? How does that work? Well, hole is if we have a term like this, and this term has to take the form of x minus a. Has to look like that, or else you can't cancel it out because it's not factored enough. But lucky for us, these terms do resemble that. X minus 2, x minus 2. So we cancel them out. So that is a hole. We have a hole at x equals, and remember flip when you're doing this, x equals 2. But a lot of times they'll say, oh, where is the point? Like not just the x, where's the y? Well, all we need to do to find that is just substitute 2 in the number that we canceled out in the remaining equation. So we have 2 plus 3 over 2 plus 2 times 2. This is 4, this is 8, and this is 5. So that's 5 over 8. So our hole, very simple, would just be at 2, because that's what we canceled out, the x value we canceled out, comma, 5 over 8, because that's the y of the canceled out x after we plug it into the finished equation. 5 over 8. That is our hole. Keep in mind, there can be more than one hole. If there are more than one pair, if there's more than one pair of terms that can cancel out, there can be more than one hole. Now, we've done that. What about vertical asymptotes, right? How do we do that? Well, you just look at the denominator and say, what terms are left? We have 2 right here. Because remember, an x on its own is just 0. So, and the reason this works is because if you get x equal to 0 on the denominator, and it multiplies the other x's, makes them all 0, you cannot divide by 0. It doesn't work. So, on the graph, it would just be a line where you cannot go, because that wouldn't be numerically possible. You can't divide by 0. So, if we were to make x equal to negative 2, it would make this expression equal to 0, and then whatever this is, negative 2 times 0 is just 0, and then dividing by 0 it doesn't work. On the same token, if we made this x here 0, then that would make this whole expression 0, and then we would also be divided by 0. So we have vertical asymptotes at x equals -2, -2, and x equals 0. X equals 0. Boom. All you gotta do. So remember, vertical asymptote is what's in the denominator after you've canceled out. Whole is the x is what you've canceled out. So this x value that you've canceled out on both the numerator and the denominator. And remember, whole, what's important about whole is that you get rid of a term in the denominator. If you get rid of a term on the numerator, it's not that important. But if this was x squared, this would still be a whole. Because although you're not getting rid of this, you're just taking off this. Because x minus 2 squared is just x minus 2, x minus 2. And then over x minus 2, this would only get rid of one of them. So the numerator would still exist, but the denominator would not. And that would be a whole. However, if we had it the other way around, like that, and it was still in the denominator, that would make it not a whole. That would make it a vertical asymptote because this still remains. Make sense? Okay. So we've got all that. Now, how do we turn this into a graph? Now, let me just clean this up. Take this, take that. Okay. We're going to bring this over here. How do we make this into a graph? And how do we make a graph into an equation? Well, we're going to draw out our lines here. We're going to say, okay, what are the different components that I have, that I know of? Well, if we look back at the full equation here, we have the bottom is a higher degree than the top, which means that the bottom of the equation will always win the arms race. It will always be getting bigger faster, and that means the function will always be dividing by a super, super high number. But it will never reach 0 because you can't divide by something and get 0. So that means that our horizontal asymptote is 0. Now, I've gone over this in the previous video, but if you haven't watched that, then you should check that out. So this is our horizontal asymptote at y equals 0. Okay, we got that. Next, vertical asymptote. Let's look at the bottom. This cancels out, and we have 2. We have x, and we have x plus 2. Or x equals -2 and 0. So we're going to go x equals -2 right here, and x equals 0. Right like that. Now we have a whole at x equals 2. What are we going to do? Well, over here is x minus 2. And we already did the math to find out where the y is. It's at 5 over 8. So x equals 2, 5 over 8. We're going to draw a circle right here. Now this circle actually tells us a lot, because we don't actually need, now that we know this is here, we don't need to plug in test values. Because we can't have, let's say the curve was down here, it never touches that hole. That wouldn't make sense. Right? So we know that the curve has to be here. But just for example's sake, we're going to plug in a test value here. So let's say anything above 0 would be a test value for this area right here. Or really this area. Right? So let's plug in 5. So x plus 3, that's 8. So 8 over 5 times 5 plus 7. 5 plus 2, 7. That's 35. 8 over 35, that's a positive number. We don't need to find that, it's just positive. So, now that we know that's positive, we know it's up here. Us knowing that the hole is there told us that anyway, but just for example's sake. And we're going to start drawing our lines. Just like that. Now you may be asking, what do I do if there's 2 vertical asymptotes? Well, you just plug in a test value over here, but 10 times out of 10, it's just going to flip. It's just going to go like that. And then it's going to flip again. Because keep in mind, these are all multiplicity 1. And remember, when you go across an area that's multiplicity 1, you flip the sign. And then you get another one here. And that's what your graph would look like for this equation right here. Right? Perfect. But now, how do we look at a graph and say, oh, I know the equation for this. And I'm actually going to use a real graph for this because these lines aren't going to cut it. You're going to have to read it. So I'll be right back. We have a very rough outline of what our graph looks like. Now, how do we make this into an equation? What do we do? Well, the key elements of a rational function can be summarized with V, H, S. And there's two H's. There's whole and there's horizontal. But whole is arguably more important. Horizontal. We have vertical. And we also have sine. So we need to understand our vertical asymptote, our whole, our horizontal asymptote, and our sine. Meaning like which side of the asymptote is the function actually on. Right? So, or really I could just put side. I like sine better. It doesn't really matter. So, first thing, we're going to find our vertical. Vertical asymptote is at 3. So that means our equation has to have x, remember flip the sign, minus 3 on the denominator, because vertical asymptotes are found on the denominator. Boom, that's one thing done. Now, whole. We have a whole at x equals 5. Now, the function doesn't actually tell you anything else. It doesn't tell you the y. It just tells you the x. So you're going to make a whole, which is when the two factors cancel out. X minus 5, x minus 5. So those would cancel out. Right? Perfect. Our horizontal. So we have to have if we were to expand these these equations, they would have to have an equal degree because they would have to divide and then get 1. So they have to have an equal degree and then have an equal leading coefficient. So we can't have 2x or 10x. We have to have x here for it to work. You know what? Scratch that. We don't need this s. What we need is zeros. Because zeros, remember, zeros are in the numerator. And that is some information that's easily available to us. Right there. There's a 0 at x equals 1. X minus 1. Now, is there any more information we're missing? We have our horizontal. If we were to multiply these, we'd get x squared, x squared. Okay, horizontal is good. X squared over x squared is 1. And then we have the horizontal at 1. Good. Vertical, we have our vertical asymptote in the denominator. Whole, we have our whole that cancels out. And 0, we have our 0 right here. So, that should be our correct answer. Very simple. I hope this helped you out. Don't worry if you want a full in-depth, or not so in-depth, but if you want a full tutorial on everything before the test, I will be making a study guide. So if you're still kind of confused and are cross-referencing videos, don't worry about it too much. I'll be making a study guide pretty soon. But I hope you enjoyed, and I hope this helped.